So now I have this original function. Let's take the integral of it, which is up 3, add 3, divide by 3. I have 1 x to the third over 3 plus c. That's for my derivative. Notice how I write it as f prime of x. Then I have this value when I plug 3 in, and I should get 6. I'm going to solve for that. 6 equals 3 times 3 times 3 is 27. Divided by 3 is 9. Subtract, so I know c on this particular equation is negative 3. Now, there is a different c for f double prime. Don't assume they're the same thing. So we got to integrate this sucker. Sucker? Where did that come from? We have to integrate our first derivative in order to figure out, sorry, I know, it's late, I'm tired. So I have to integrate this thing, add 4, add 1 to it, I get 4, divide by 4, and there's a 3 already there, so 3 times the 4, and then I have to go up a level with that, plus a c. So don't forget that little aspect of the thing. And now I have a point on this function. This c is different than that c. If you are easily confused, you may want to put it that this is c1 and that this is a different one. We'll call it c2. Plug in your 6 into your x. Plug in your 6 into your x. Plug in your negative 10. You might want to use a calculator. This one's kind of a big one. You get that c is negative 100, and now you have your original function. And I say all that, the best part of this whole thing is that now we can figure out accelerations, velocities, and positions. So when I think about how this applies to physics, those of you going into AP Physics C, then this is going to be right up your alley. Those of you going into AP Physics part number 1 next year, this is also going to be easy for you. A ball is thrown upward at t equals 1 second. It had a velocity of 32 feet per second and a height of 128 feet. If negative 32 feet per second squared is the acceleration due to gravity, what are the position and velocity formulas, and when does the ball hit the ground? Okay. So the very first thing that we have to start with is the acceleration due to gravity. If you don't know, what we learned in Unit 2, Chapter 2, was position. The derivative of position was velocity, and the derivative of velocity was acceleration. So if I start off with a second derivative, and I put s double prime of t equals negative 32, I'm starting off with, if negative 32 feet per second squared is the acceleration due to gravity, this piece tells me what my second derivative is. And now, if you integrate it, let's integrate this. Let's take the integral, which will take us up to s prime of t. And if I take that, if that means that's going to be the velocity formula. Let's do that real quick. That means the integral of this here with respect to time, that's why it's dt, is going to be my first derivative, otherwise known as my velocity formula. Let's do that. Let's add a variable t and divide by 1. Plus c gives me this. I know one fact. At t equals 1 second, it had a velocity of 32 feet per second. That is 1 point on this derivative. At 1 second, that's your t, it had a velocity equals 32. Let's plug that in. Do you know what the constant has to be? Negative 32, add it, c is equal to 64. Now we have our velocity formula. What are position and velocity formulas? We've answered one of our questions. but I need the position formula. So what do I need to do to this velocity formula? I'm hoping you realize you need to integrate it. When you integrate this with respect to time, which I don't see it in my work like I did over here, when I integrate it with respect to time, I'm now at the position formula, aren't I? Okay, I feel like there should be a d over t here, and there's not, and that bugs me. So add that to your notes. Add 2, divide by 2. Ooh, there's that number again because we're in feet per second. Add t. We don't have the constant of integration. Don't forget the extra, the c. This c is different, by the way, than this c, so don't get it confused with each other. And now that we have that, we know that it had a velocity of 32 feet per second and a height of 128. There's the position. At 1 second, it should be 128. Can I plug that into the position formula? Plug in your 1 second is 128 feet. Negative 16 plus 64 is, I have no idea. And then you subtract that from 128 and you get 80. Does that sound right to you? And that is your position formula. So I've answered these two questions, position and velocity formulas. There's only one last question I have to answer, which is, when does the ball hit the ground? I want to know at what time the position is 0. So set this equal to 0. If you can factor out something, do that. I'd factor out a 16 if I were you. And it factors perfectly. You know 2 possibilities. Guess which of your possibility you're going to pick here for time? Exactly. We're not going to go back in time 1 second. We're only going to pick the 5 seconds from now. That's what we'll do. So perfect. That's how this is going to work. This is the hardest that it gets, I guess, is like that. And so we have one more problem. Let me let you read this problem. You might need to press pause real quick while students read this. This is the hardest that it gets, is to figure out how much velocity an object must be thrown upward from ground level to reach the top of the wreck if negative 32 feet per second squared is the acceleration due to gravity. So let's do the hardest that it gets. Actually, I'm going to save that for video 3 because when I'm recording these notes, the bell's about to ring. So I need to stop it right here.